In the depths of space, 13.8 billion light-years away, astronomers have detected something that defies explanation. A massive structure called the cold spot, a region of space so perfectly void of matter that it spans 1.8 billion light-years across. According to our understanding of cosmic evolution, this shouldn't exist. The universe should be random, chaotic, filled with the messy aftermath of the Big Bang. Yet here we find geometric precision on a scale so vast it challenges everything we thought we knew about reality. But the cold spot is just the beginning. From the quantum realm to the cosmic web, from the fine-tuning of physical constants to the emergence of consciousness itself, our universe displays patterns, ratios, and relationships that seem almost intentional. For centuries, we've assumed the universe is the product of random chance, that given enough time and space, complexity would inevitably emerge from chaos. Stars would form, planets would coalesce, and eventually, life would find a way. But what if this assumption is wrong? What if the mathematical precision we observe, the delicate balance that allows galaxies to form and life to flourish, isn't the result of cosmic lottery but cosmic design? Consider liking and subscribing to the channel as we're going to explore one of the most profound questions ever asked. What if the universe was designed, not by chance, not by accident, but with purpose and intention? We'll examine the evidence that's causing even the most skeptical scientists to question their assumptions about reality itself. Let's start with what physicists call the fine-tuning problem, and it's a problem that keeps cosmologists awake at night. Imagine you're standing before the most complex machine ever built. This machine has dozens of dials, each representing a fundamental force or constant in the universe. There's a dial for gravity, one for electromagnetic force, another for the speed of light, and many more. Now here's the catch. If any of these dials is turned even slightly from its current position, the entire machine breaks down. Not just malfunctions, but completely ceases to work. This is our universe. Take gravity, for instance. If gravity were just slightly stronger, we're talking about a change of 1 part in 10 to the power of 40. That's a decimal point followed by 39 zeros, and then a 1 stars would burn out in millions of years instead of billions. There would be no time for planets to form, let alone life to evolve. Make gravity slightly weaker, and matter would never clump together to form stars in the first place. The universe would be a cold, dark, empty void. But gravity is just one dial. The electromagnetic force that holds atoms together? If it were 4% stronger, there would be no hydrogen in the universe, and without hydrogen, no water, no stars as we know them. Make it weaker, and atoms couldn't form stable bonds. No chemistry means no life. Then there's the cosmological constant, the mysterious force causing the universe's expansion to accelerate. This dial is set so precisely that if it were off by 1 part in 10 to the power of 120, that's more precise than hitting a target the size of a single atom from 13 billion light-years away. The universe would either collapse immediately after the Big Bang or expand so rapidly that no structures could ever form. Dr. Martin Rees, the British cosmologist, identified 6 fundamental numbers that govern our universe. He calculated that if any of these numbers were altered by even tiny amounts, we would have a universe where no complexity could arise, no stars, no planets, no chemistry, no life. But here's where it gets really mind-bending. These aren't just a few lucky coincidences. We're talking about dozens of parameters, all of which must fall within incredibly narrow ranges for a universe like ours to exist. The probability of this happening by chance? According to physicist Roger Penrose, it's roughly 1 in 10 carat 10 carat 123. To put this in perspective, There are only about 10 to the power of 80 atoms in the observable universe. Some scientists have tried to explain this away with the anthropic principle, the idea that we observe these conditions simply because we're here to observe them. In other words, if the universe weren't fine-tuned, we wouldn't exist to notice. But this explanation has always felt like intellectual sleight of hand. It's like walking into a room where 100 darts have been thrown at a dartboard and every single one hit the bullseye, then shrugging and saying, "Well, of course they all hit the target. Otherwise, I wouldn't be here to see them." Faced with this uncomfortable precision, many physicists have retreated to the multiverse hypothesis. The idea is simple. If there are infinite universes with every possible combination of physical laws, then by sheer probability, some universes will have the right conditions for complexity and life. We just happen to find ourselves in one of the rare Goldilocks universes where everything is just right. It's an elegant solution, but it comes with a massive philosophical cost. To explain the apparent design in our universe, we must postulate an infinite number of unobservable universes. We're essentially saying that to avoid the possibility of design, we'll accept the existence of infinite realities we can never detect or verify. Think about what this means. For every universe where you exist, there are countless others where you don't. There are universes where the laws of physics are different, where time runs backward, where consciousness never emerged. The multiverse theory asks us to believe that all of these exist, even though we can never prove it. But even if we accept the multiverse, the design problem doesn't go away, it just moves up a level. What designed the multiverse generator itself? What fine-tuned the laws that govern the creation of universes? If there's a mechanism capable of producing infinite universes with varying physical constants, that mechanism itself must operate according to some set of rules or principles. Who or what established those meta-rules? Dr. David Chalmers, the philosopher and cognitive scientist, has pointed out that the multiverse hypothesis suffers from what he calls the Boltzmann brain problem. In an infinite multiverse, it's actually more likely that your consciousness is a random fluctuation in empty space, a Boltzmann brain with false memories of a life that never happened, than a product of evolutionary development in a real universe. If we take the multiverse seriously, we should conclude that nothing we observe is real. But the fine-tuning of physical constants is just the tip of the iceberg. There's something even more mysterious about our universe. It appears to be fundamentally mathematical in nature. When Galileo wrote that mathematics is the language in which God has written the universe, he was making an observation that still puzzles scientists today. Why should physical reality conform so perfectly to mathematical descriptions? Why do the most abstract mathematical concepts, developed purely in the realm of human thought, turn out to describe the deepest workings of nature? Take the golden ratio, approximately 1.618, a number that appears throughout art and architecture because it's aesthetically pleasing to human perception. But this same ratio shows up everywhere in nature, in the spiral of nautilus shells, the arrangement of seeds in sunflowers, the proportions of the human body, the structure of galaxies. It's as if the universe has an inherent sense of mathematical beauty. Or consider the mathematical constants that govern physical reality. Pi, the ratio of a circle's circumference to its diameter, shows up in quantum mechanics, general relativity, and statistical distributions. Euler's number E appears in everything from radioactive decay to population growth. These aren't just convenient mathematical tools. They seem to be woven into the fabric of reality itself. The physicist Eugene Wigner called this the unreasonable effectiveness of mathematics in the natural sciences. It's unreasonable because there's no obvious reason why abstract mathematical concepts should correspond so precisely to physical phenomena. Mathematics is a product of human minds, yet it describes a universe that existed long before minds evolved to contemplate it. Albert Einstein was deeply struck by this mystery. He once said, "The most incomprehensible thing about the universe is that it is comprehensible. But what if it's comprehensible precisely because it was designed to be comprehensible? What if the mathematical nature of reality isn't a cosmic coincidence but evidence of an underlying intelligence that thinks mathematically?" Let's examine how complexity builds in our universe, because the pattern is remarkable. At the quantum level, we have particles that can exist in multiple states simultaneously, what physicists call superposition. These particles follow mathematical rules so precise that we can predict their behavior with incredible accuracy. From this quantum foundation, atoms emerge with their own set of rules and properties. Atoms combine to form molecules, and suddenly new properties emerge that couldn't be predicted from studying individual atoms alone. Water is wet, but neither hydrogen nor oxygen is wet individually. This emergence of new properties from simpler components is a pattern that repeats throughout nature. Molecules organize into cells, and cells display the mysterious property we call life. Life exhibits characteristics, metabolism, reproduction, response to environment that no non-living molecule possesses. From single cells emerge multicellular organisms with even greater complexity. In some organisms, neural networks develop, and from these networks emerges consciousness, perhaps the most mysterious phenomenon in the universe. Consciousness allows matter to become aware of itself, to contemplate its own existence, to discover mathematical laws, to create art and music and poetry. This isn't just complexity, it's a specific type of complexity that builds hierarchically, with each level displaying properties that transcend the sum of its parts. It's as if the universe has an inherent tendency toward organization, toward the emergence of higher-order structures and capabilities. But here's the truly remarkable thing. Each level of this hierarchy seems designed to support the next. The quantum properties of atoms allow for chemical bonding. Chemical bonding allows for the complex molecules necessary for life. The properties of life allow for the development of neural systems. Neural systems allow for consciousness. It's like finding a vast cosmic construction project where each phase of building perfectly prepares the foundation for the next phase. The early universe was dominated by the formation of hydrogen and helium, the perfect stellar fuel. Stars then forged the heavier elements necessary for planets and life. Planets provided stable environments for the development of complex chemistry, and so on. But perhaps the most compelling evidence for design lies in the realm of information. Information is different from matter and energy. It's the arrangement, the pattern, the organization that gives meaning to physical structures. The same atoms that make up a pile of sand can be rearranged to form a computer processor. The difference isn't in the materials but in the information, the specific arrangement of those materials. Here's what's fascinating. Our universe appears to be fundamentally informational in nature. Quantum mechanics suggests that at the deepest level, reality consists of information states. When we measure a quantum particle, we're not discovering pre-existing properties, we're actualizing information possibilities into physical reality. John Wheeler, the physicist who coined the term black hole, proposed that the universe operates on what he called it from bit, the idea that all physical entities are information theoretic in origin. In other words, matter and energy might be secondary to information. But where does information come from? In our experience, meaningful information always has a source. The information in a book comes from an author. The information in DNA comes from what? Random mutations? But random processes destroy information. They don't create it. Consider the DNA in a single human cell. It contains roughly 3 billion base pairs, encoding information equivalent to about 750 megabytes of data. This information specifies the instructions for building and operating one of the most complex structures in the known universe, a living organism capable of growth, reproduction, and in some cases, consciousness. The probability of such information arising by chance is vanishingly small. Bill Gates, the founder of Microsoft, once observed that DNA is like a computer program but far more advanced than any software ever created. Yet we're asked to believe that this software wrote itself through purely random processes. Even more puzzling is the fact that DNA information is universal. The genetic code that specifies how DNA sequences translate into proteins is nearly identical across all life forms on Earth. From bacteria to humans, the same informational system operates. It's as if all life was designed to use the same programming language. When we zoom out to look at the universe on its largest scales, the evidence for design becomes even more striking. The cosmic web, the largest structure in the universe, consists of vast filaments of galaxies separated by enormous voids. From a distance, it looks remarkably like neural networks in the brain or the mycelium networks of fungi. This similarity across vastly different scales suggests some kind of universal organizing principle. But it's not just the appearance that's remarkable, it's the precision. Computer simulations show that if the initial density fluctuations in the early universe had been even slightly different, we would have a universe either empty of large structures or collapsed into black holes. The parameters were set just right to allow for the formation of galaxies, which then allowed for the formation of stars, which then allowed for the formation of planets. The cosmic microwave background, the afterglow of the Big Bang, shows tiny temperature variations that served as the seeds for all large-scale structure in the universe. These variations are incredibly uniform, yet contain just enough irregularity to allow matter to clump together. Too uniform and no structures would form. Too irregular, and the universe would have collapsed early or expanded too rapidly for gravity to work. What's even more remarkable is that these cosmic structures seem optimized for the development of complexity. Galaxies provide the perfect environments for star formation and heavy element production. Solar systems provide stable zones where planets can maintain liquid water. It's as if the universe was designed as a vast nursery for the development of complexity and life. The Goldilocks problem, finding conditions that are just right, appears at every level of cosmic organization. Our galaxy, the Milky Way, is just the right size. Smaller galaxies don't have enough heavy elements to form rocky planets. Larger galaxies have too much stellar activity and radiation for stable planetary systems. We're located in just the right position within the galaxy, far enough from the center to avoid deadly radiation, close enough to have access to the heavy elements forged in stellar cores. Our solar system displays the same precision. Jupiter acts as a cosmic vacuum cleaner, sweeping up asteroids and comets that might otherwise bombard Earth. But if Jupiter were larger or in a different orbit, it would destabilize Earth's orbit. The Moon is just the right size to stabilize Earth's axial tilt, preventing extreme climate variations. It also creates tides that may have been crucial for the transition of life from ocean to land. Earth itself is a masterpiece of fine-tuning. Its size gives it just enough gravity to hold an atmosphere, but not so much that it becomes a gas giant. Its distance from the Sun places it in the narrow habitable zone, where water can exist as a liquid. Its magnetic field protects us from deadly cosmic radiation. Its plate tectonics regulate global temperature and recycle nutrients necessary for life. Even Earth's atmosphere seems designed for life. The ratio of oxygen to nitrogen is perfect for complex organisms, enough oxygen to support metabolism, enough nitrogen to prevent oxygen toxicity. The greenhouse effect keeps our planet warm enough for liquid water. The ozone layer shields us from ultraviolet radiation. But here's what's truly remarkable. All of these Goldilocks conditions had to be in place simultaneously. It's not enough for just one or two parameters to be right. They all had to be right at the same time. The probability of this happening by chance across so many independent variables is astronomically small. But perhaps the most profound mystery of all is consciousness itself. Consciousness is the universe becoming aware of itself. Through conscious beings, the cosmos develops the ability to contemplate its own existence, to marvel at its own beauty, to discover its own laws. In a very real sense, consciousness is the universe's way of understanding itself. Yet consciousness remains the hardest problem in science. We can explain the functional aspects of the brain, how neurons fire, how information is processed, how behaviors are generated. But we cannot explain why there is something it is like to be conscious. Why should the processing of information be accompanied by subjective experience? The philosopher David Chalmers calls this the hard problem of consciousness. We can explain the brain's cognitive functions, but we cannot explain qualia, the redness of red, the pain of pain, the experience of being you. There seems to be an unbridgeable gap between objective physical processes and subjective conscious experience. Some scientists have proposed that consciousness is an emergent property of complex information processing. But emergence doesn't explain subjective experience. It only explains new functional capabilities. A computer can process information far more efficiently than any brain, but there's no reason to believe it experiences anything. Others suggest that consciousness is fundamental to the universe, that the capacity for experience is built into the fabric of reality itself. This view, called panpsychism, suggests that consciousness isn't produced by matter but is rather an intrinsic aspect of matter, like mass or charge. If consciousness is fundamental, then the universe has been designed from the beginning to support conscious experience. The fine-tuning of physical laws, the emergence of complexity, the development of life, all of it could be seen as a cosmic process leading inevitably toward consciousness. Think about what this means. The universe spent 13.8 billion years preparing for conscious beings. Stars lived and died to forge the elements in your body. Galaxies formed and evolved to create stable environments. Planets formed and developed complex chemistry. Life emerged and evolved for billions of years. All of this vast cosmic drama, just so that matter could eventually become aware of its own existence. Earlier, we touched on the anthropic principle, the idea that we observe fine-tuning simply because we exist to observe it. But there are actually two forms of this principle, and the distinction is crucial. The weak anthropic principle simply states that we observe a universe compatible with our existence because we're here to observe it. This is logically sound but explanatorily empty. It's like saying we find ourselves in a house because we can't observe houses we're not in. The strong anthropic principle goes further, suggesting that the universe must have properties that allow consciousness to develop within it. This version implies that consciousness is not accidental but somehow necessary or inevitable. But there's an even stronger version that some physicists and philosophers have proposed, the participatory anthropic principle. This suggests that consciousness doesn't just observe the universe, it participates in creating it. Quantum mechanics tells us that observation plays a fundamental role in physical reality. The act of measurement doesn't just reveal pre-existing properties, it actualizes specific outcomes from quantum possibilities. In a sense, consciousness collapses the wave function of reality. John Wheeler proposed that we live in a participatory universe, where consciousness is not just an observer but a participant in the cosmic drama. The universe brings forth consciousness, and consciousness brings forth the classical reality we experience. If this is true, then the universe isn't just fine-tuned for consciousness, it requires consciousness to become fully real. The cosmic fine-tuning we observe might not be a coincidence or even a design feature, but a necessary condition for a self-actualizing universe. This brings us to one of the most mind-bending possibilities of all. What if our universe is actually a vast computation? Digital physics suggests that reality might be fundamentally computational. Instead of matter and energy being primary, information processing might be the fundamental substrate of existence. In this view, particles don't have properties. They process information. Forces don't push and pull. They compute interactions. There's growing evidence for this perspective. The universe appears to have a minimum unit of space, the Planck length, and time, the Planck time, suggesting a granular, pixel-like structure reminiscent of a digital system. Quantum mechanics operates through discrete energy levels and probabilistic calculations that seem computational in nature. The physicist John Wheeler proposed that reality emerges from information processing, it from bit. Every physical interaction can be understood as an information exchange. When particles collide, they're not just transferring energy, they're computing the outcome of their interaction. But if the universe is computational, what's running the computation? This leads to the simulation hypothesis, popularized by philosopher Nick Bostrom. If advanced civilizations develop sufficient computational power, they might run detailed simulations of entire universes, complete with conscious beings who believe they're living in physical reality. The fine-tuning we observe could be the result of simulation parameters set by the beings running our reality. The mathematical nature of physical laws could reflect the computational substrate underlying our existence. The emergence of consciousness could be the whole point of the simulation, to create beings capable of experiencing and understanding reality. This might sound like science fiction, but several respected physicists take it seriously. Elon Musk has stated that the odds we're living in base reality are billions to 1. If the simulation hypothesis is correct, then our universe literally is designed, programmed by intelligence far beyond our current understanding. If the universe is designed, what kind of intelligence could be responsible for such a vast and intricate creation? Traditional religious perspectives have long maintained that the universe reflects divine intelligence. The fine-tuning of physical constants, the mathematical nature of reality, the emergence of consciousness, all point toward a transcendent designer with capabilities far beyond anything in the natural world. But modern science suggests even more extraordinary possibilities. If our universe is one of many, then the intelligence responsible for universal design might be operating at a level we can barely comprehend. Such a being would need to understand mathematics and physics at a depth that allows manipulation of the fundamental constants of reality. Alternatively, the designer might be a hyper-advanced civilization from another universe or dimension. Just as we're beginning to simulate simple biological systems, a sufficiently advanced civilization might be capable of simulating entire universes, complete with conscious beings. Or perhaps the intelligence is distributed throughout the cosmos itself. The panpsychist view suggests that consciousness is fundamental to reality. What if the universe as a whole possesses a form of consciousness, a cosmic mind of which we are all part? There's also the possibility that the designer is temporal rather than spatial, an intelligence that exists outside of time and can perceive the entire history of the universe simultaneously. From such a perspective, the fine-tuning of initial conditions and the emergence of consciousness would be part of a single, coherent design. Some theories in physics suggest that information is more fundamental than matter or energy. If this is true, then the ultimate designer might be pure information, a pattern or algorithm so complex and self-organizing that it gives rise to entire realities. If the universe is designed, what purpose does it serve? One possibility is that the universe exists to generate conscious experience. The fine-tuning of physical laws, the emergence of complexity, the development of life, all of it could be aimed at creating beings capable of awareness, understanding, and appreciation of existence itself. In this view, consciousness is not an accident but the goal. The universe spent billions of years preparing the stage for conscious beings to emerge and begin the process of self-understanding. Every star that formed, every planet that developed, every species that evolved was part of a vast cosmic project to bring awareness into existence. Another possibility is that the universe is designed as a learning system. Perhaps consciousness develops not just to experience reality but to understand it, to uncover its deepest principles, to eventually become capable of creating new realities. In this scenario, we are not just observers but apprentice creators, learning the craft of universe making. The universe might also serve as a testing or development environment. If we exist in a simulation run by advanced beings, the purpose might be to explore possibilities, to see how consciousness develops under different conditions, to answer fundamental questions about the nature of existence and intelligence. Or perhaps the purpose is purely aesthetic, the universe as the ultimate work of art. The mathematical beauty of physical laws, the elegant symmetries of nature, the breathtaking vistas of cosmic structure, all of it could be an expression of cosmic creativity, designed to be appreciated by beings capable of recognizing beauty. There's also the intriguing possibility that the universe is designed to design itself. Through the emergence of consciousness and intelligence, the cosmos becomes capable of understanding and eventually modifying its own structure. We might be part of the universe's process of self-improvement and self-transcendence. Let's delve deeper into some specific examples of cosmic fine-tuning that suggest design. The fine structure constant, denoted by the Greek letter alpha, is approximately 1/137. This dimensionless number determines the strength of electromagnetic interactions. It governs how tightly electrons bind to atomic nuclei, how atoms absorb and emit light, and countless other electromagnetic phenomena. What makes alpha so special? First, it's dimensionless. It's a pure number that doesn't depend on any system of units. Second, it appears to be fundamental. It can't be derived from other constants or principles. Third, it's incredibly precisely tuned for complexity. If alpha were larger, electrons would spiral into atomic nuclei, making atoms unstable. If it were smaller, atoms couldn't form chemical bonds. The value of 1/137 sits in the narrow window that allows for stable atoms and complex chemistry. But here's the really mysterious part. Alpha is related to other fundamental constants through mathematical relationships that seem almost too elegant to be accidental. The physicist Richard Feynman called alpha one of the greatest damn mysteries of physics, and suggested that all good theoretical physicists should worry about this number. Then there's the cosmic coincidence problem. The energy density of dark matter and the energy density of ordinary matter are remarkably similar in today's universe, despite the fact that they dilute at different rates as the universe expands. This similarity is temporary. In the past, matter dominated, and in the future, dark energy will dominate. We happen to live during the brief cosmic epoch when these densities are comparable. Why is this significant? This balance affects the rate of structure formation in the universe. If dark matter dominated too strongly, structure would form too quickly and collapse. If ordinary matter dominated, structure formation would be suppressed. The current balance allows for the gradual formation of galaxies, stars, and planetary systems. The fine-tuning extends into biology itself, suggesting that life as we know it depends on incredibly precise conditions. Consider water, the most common molecule in living organisms. Water has dozens of unusual properties that seem perfectly suited for life. It's one of the few substances that becomes less dense when it freezes, meaning ice floats and insulates the liquid water below. Its high specific heat capacity helps regulate temperature in living organisms. Its molecular polarity makes it an excellent solvent for biological molecules. But water's most remarkable property might be its hydrogen bonding. The slight positive charge on hydrogen atoms and the slight negative charge on oxygen atoms allow water molecules to form temporary bonds with each other. This gives water its high boiling point, surface tension, and many other life-supporting properties. The strength of hydrogen bonding is precisely calibrated. Stronger bonding would make water too viscous for biological processes. Weaker bonding would eliminate many of water's unique properties. The actual strength falls in the narrow range that maximizes water's utility for life. Carbon, the backbone of organic molecules, displays similar fine-tuning. Carbon can form 4 strong covalent bonds, allowing for incredible molecular complexity. It can form single, double, and triple bonds, creating a vast array of possible structures. Carbon chains can be straight, branched, or cyclic, and can incorporate other elements to create functional groups. But carbon's ability to form complex molecules depends on precise atomic properties. The size of carbon atoms, the strength of carbon-carbon bonds, and the angles between bonds are all perfectly suited for creating stable yet reactive organic molecules. Even more remarkable is the fact that carbon is abundant in the universe despite being difficult to create. Carbon is forged in stellar cores through the triple alpha process, where 3 helium nuclei combine almost simultaneously. This process requires an incredibly precise energy level in the carbon nucleus, a level that was predicted theoretically and later confirmed experimentally. Fred Hoyle, the astronomer who discovered this carbon resonance, was so amazed by its precision that he remarked, "A common-sense interpretation of the facts suggests that a superintellect has monkeyed with physics, as well as with chemistry and biology." Modern biology has revealed that life is fundamentally based on information processing, not just chemistry. DNA serves as a digital information storage system, encoding instructions for building and operating living organisms. But DNA is just the beginning. The cell contains multiple layers of information processing: RNA molecules that copy and modify genetic information, proteins that execute cellular programs, and complex regulatory networks that control when and how genetic information is expressed. The genetic code, the mapping between DNA sequences and amino acid sequences, appears to be optimized for error tolerance. Computer scientists have analyzed the standard genetic code and found that it's remarkably resistant to the types of errors that commonly occur during DNA replication and transcription. The code seems designed to minimize the harmful effects of mutations. Even more intriguing is the fact that the genetic code contains redundancy. Multiple DNA sequences can code for the same amino acid. This redundancy isn't random but follows patterns that maximize the code's robustness. It's as if the code was designed by an information theorist seeking to optimize communication in a noisy channel. Epigenetic mechanisms add another layer of information processing. Chemical modifications to DNA and histones can change how genes are expressed without changing the underlying genetic sequence. These modifications can be influenced by environmental factors and can sometimes be inherited across generations. The cell also contains sophisticated error correction mechanisms. DNA repair systems can detect and fix many types of genetic damage. proofreading mechanisms check the accuracy of DNA replication and protein synthesis. Quality control systems ensure that defective proteins are identified and destroyed. All of this suggests that life is not just chemistry but information processing, and sophisticated information processing at that. The cell is like a biological computer processing genetic software to generate the complex behaviors we call life. One of the most striking patterns in biology is convergent evolution, the tendency for unrelated organisms to independently develop similar solutions to environmental challenges. Eyes have evolved independently at least 40 times in different lineages. Despite their different evolutionary origins, many of these eyes converge on remarkably similar designs. Camera eyes like ours have evolved independently in vertebrates, mollusks, and some cnidarians. Compound eyes appear in arthropods and some mollusks. Each type represents an optimal solution to the problem of detecting and processing light. The physics of flight imposes strict constraints on flying organisms. As a result, birds, bats, and insects have all converged on similar wing designs and flight mechanics. The mathematics of aerodynamics seems to guide evolution toward optimal solutions. Echolocation has evolved independently in dolphins, whales, and bats. All use high-frequency sounds and sophisticated neural processing to create detailed acoustic images of their environment. The principles of sonar guide these species toward similar solutions. Even at the molecular level, we see convergent evolution. The active sites of enzymes often converge on similar structures, even when the enzymes evolved independently. This suggests that there are optimal solutions to biochemical problems, and evolution consistently discovers these solutions. This pattern of convergent evolution suggests that the space of possible biological solutions is not random but structured. There appear to be optimal solutions to biological problems, and evolution reliably discovers these optima. It's as if the laws of physics and chemistry channel biological evolution toward predetermined solutions. Some biologists have proposed that this reflects underlying laws of form and function, that there are mathematical principles governing biological structure just as there are principles governing physical and chemical systems. In this view, evolution doesn't create solutions randomly but discovers pre-existing optimal designs. Let's return to what may be the most severe fine-tuning problem in physics: the cosmological constant. The cosmological constant represents the energy density of empty space itself, what physicists call vacuum energy or dark energy. This mysterious energy is causing the expansion of the universe to accelerate, working against the attractive force of gravity. Quantum field theory predicts that empty space should be seething with virtual particles, particle-antiparticle pairs that pop into existence and annihilate almost instantly. The energy associated with these virtual particles should contribute to the cosmological constant. Here's the problem. When physicists calculate what the cosmological constant should be based on quantum field theory, they get a number that's about 10 to the power of 120 times larger than what we observe. This is the largest discrepancy between theory and observation in the history of science. If the cosmological constant were even close to the theoretical prediction, the universe would have expanded so rapidly that no structures could ever form, no galaxies, no stars, no planets, no life. Space itself would be expanding faster than light, preventing any regions from gravitationally collapsing to form cosmic structures. The observed value is not just smaller than predicted, it's precisely tuned to allow for cosmic structure formation. If it were much larger, the universe would expand too rapidly for gravity to work. If it were negative and too large in magnitude, the universe would collapse before stars could form. But there's another layer to this mystery. The cosmological constant becomes important for cosmic evolution only recently in the universe's history. For most of cosmic time, matter and radiation dominated the universe's energy density. Only in the last few billion years has dark energy become dominant. This timing seems suspicious. Dark energy becomes important just as the universe has developed complex structures and life. Earlier, and structure formation would have been prevented. Much later, an intelligent life might not have had time to evolve before dark energy drove all galaxies beyond our cosmic horizon. Some physicists have proposed that the cosmological constant varies over time or space, allowing for regions where its value permits structure formation. But this still requires some mechanism to generate the right value in the right place at the right time. The fine-tuning issues extend throughout particle physics in what's known as the hierarchy problem. The Higgs field, discovered at the Large Hadron Collider, gives mass to fundamental particles. But the mass of the Higgs particle itself should receive enormous quantum corrections from virtual particles. These corrections should make the Higgs mass about 10 to the power of 16 times larger than observed. For the Higgs to have its observed mass, there must be incredibly precise cancellations between different quantum contributions. The level of fine-tuning required is similar to adjusting a dial to 1 part in 10 to the power of 32, like hitting a target the size of an atom from the distance of the solar system. This problem of naturalness pervades particle physics. Many parameters require precise fine-tuning to have their observed values. The masses of fundamental particles, the strengths of forces, and the ratios between different energy scales all seem to require miraculous cancellations of quantum effects. Some physicists hoped that supersymmetry, a proposed symmetry between matter particles and force particles, would solve the hierarchy problem by providing natural cancellations. But the Large Hadron Collider has found no evidence for supersymmetric particles, leaving the fine-tuning problem unsolved. Others have proposed extra dimensions or other exotic physics to explain the hierarchy problem. But these solutions often introduce their own fine-tuning requirements. It seems that no matter how we try to explain away the fine-tuning, it reappears at a deeper level. The naturalness problem suggests that our current understanding of physics is incomplete. Either there are unknown principles that naturally explain the observed values, or the universe really is fine-tuned to an extraordinary degree. At the heart of quantum mechanics lies one of the deepest mysteries in science: the measurement problem. Quantum systems exist in superposition. They can be in multiple states simultaneously until they're measured. An electron can spin both clockwise and counterclockwise. A photon can pass through 2 slits at once. A particle can be in multiple locations. But when we observe these systems, we always see definite outcomes. The standard interpretation says that measurement collapses the wave function. It forces the quantum system to choose a definite state. But this raises profound questions. What counts as a measurement? When exactly does collapse occur? Why do we see one outcome rather than another? Some physicists propose that consciousness plays a fundamental role in quantum mechanics. In this view, conscious observation is what causes wave function collapse. The universe exists in quantum superposition until conscious beings observe it and actualize specific realities. If consciousness is necessary for wave function collapse, then the universe literally cannot become classical and definite without conscious observers. The fine-tuning that allows for the emergence of consciousness isn't just convenient, it's necessary for the universe to become real in any meaningful sense. This interpretation suggests that the universe is designed not just to produce conscious beings, but to require them for its own actualization. Consciousness and cosmos are locked in a cosmic dance where each brings the other into being. Other interpretations avoid the consciousness requirement but introduce their own mysteries. The many worlds interpretation says that all possible outcomes occur in parallel universes, and we experience only one branch of an infinitely splitting reality. But this multiplies the design problem. Now we need fine-tuning across infinite realities. The pilot wave interpretation maintains that particles have definite positions and velocities at all times, guided by a quantum field. But this field must be precisely structured to reproduce all quantum phenomena, suggesting another layer of cosmic design. Perhaps the most profound question of all is why mathematics works so well to describe reality. Mathematics is a purely abstract creation of human minds. We define numbers, geometric shapes, algebraic structures, and logical relationships through pure thought. Yet these mental constructions turn out to describe the physical world with uncanny precision. The equations of physics are not just approximate descriptions. They often capture the behavior of natural systems with perfect accuracy. Einstein's equations predict the behavior of space and time. Schrödinger's equation governs quantum systems. Maxwell's equations describe electromagnetic phenomena. These are exact mathematical relationships, not rough approximations. But why should abstract mathematical concepts correspond to physical reality? Why should the products of human imagination match the structure of the cosmos? One possibility is that mathematics is discovered rather than invented. In this view, mathematical truths exist independently of human minds, and we gradually uncover these eternal relationships. The universe conforms to mathematical principles because mathematical principles are fundamental aspects of reality. This Platonic view of mathematics suggests that abstract mathematical objects, numbers, geometric forms, logical structures, exist in a realm beyond space and time. Physical reality then becomes a manifestation or shadow of these perfect mathematical forms. If this is true, then the mathematical nature of physical laws isn't coincidental but necessary. The universe must be mathematical because mathematics is the fundamental substrate of existence. The fine-tuning we observe reflects the mathematical harmony underlying reality. Another possibility is that consciousness and mathematics co-evolved. Perhaps the universe develops mathematical structure precisely to support the emergence of minds capable of understanding mathematics. In this view, the cosmos is engaged in a process of self-understanding, using conscious beings as instruments of cosmic self-awareness. The mathematician Eugene Wigner noted that mathematics is unreasonably effective in describing nature. But perhaps it's not unreasonable at all. Perhaps the effectiveness of mathematics is evidence that reality is fundamentally designed to be comprehensible to mathematical minds. String theory, our most ambitious attempt at a theory of everything, has revealed what physicists call the landscape problem. String theory suggests that there may be 10 to the power of 500 different ways to configure the extra dimensions that the theory requires. Each configuration would produce a universe with different physical laws and constants. This creates a vast landscape of possible universes. Some physicists have embraced this landscape as a solution to the fine-tuning problem. If there are 10 to the power of 500 possible universes, surely some will have the right properties for complexity and life. We find ourselves in one of the rare habitable universes simply because we couldn't exist in the others. But this landscape approach faces several problems. First, 10 to the power of 500 is still finite, and the fine-tuning requirements may be even more restrictive than this number allows. Second, the landscape itself requires explanation. Why these particular configurations and not others? More fundamentally, the landscape approach doesn't eliminate design, it just pushes the design question to a higher level. What designed the rules that govern the string landscape? What determined that there should be exactly these possible configurations and not others? The anthropic landscape also suffers from what philosophers call the reference class problem. If we're randomly selected from all conscious beings in the multiverse, we should expect to find ourselves as typical observers. But this leads to disturbing conclusions about the nature of consciousness and reality. Moreover, the landscape approach makes physics less predictive. Instead of explaining why the universe has its observed properties, we're told that it's just one possibility among countless others. This transforms physics from a predictive science into a kind of cosmic natural history. A growing number of physicists are taking seriously the idea that reality is fundamentally computational. Digital physics proposes that the universe is a discrete system processing information according to simple rules. Instead of continuous space and time, reality consists of tiny discrete units, pixels of existence that update according to computational algorithms. There's mounting evidence for this view. The universe appears to have fundamental limits, maximum speeds, minimum distances, discrete energy levels that suggest an underlying digital structure. Quantum mechanics operates through probabilistic calculations that look remarkably like computational processes. The holographic principle in physics suggests that all the information in a volume of space can be encoded on its two-dimensional boundary. This is exactly what we'd expect if reality were a kind of holographic projection from a lower-dimensional computational substrate. If the universe is computational, then the fine-tuning we observe could reflect the parameters of the cosmic program. The mathematical laws of physics would be the algorithms governing reality's computation. The emergence of complexity and consciousness would be the intended output of the cosmic calculation. This computational view also explains why mathematics is so effective in describing nature. Mathematics is the language of computation, so a computational universe would naturally conform to mathematical description. But if reality is computational, what's running the computation? This brings us back to the question of cosmic design. A computational universe requires something to execute the computation hardware capable of running the cosmic program. All of these considerations point toward consciousness as the key to understanding cosmic design. Consciousness is the universe's strangest and most remarkable property. Through conscious beings, the cosmos becomes aware of itself, understands its own structure, and contemplates its own existence. Consciousness transforms the universe from a collection of particles and forces into a realm of experience, meaning, and understanding. But consciousness may be more than just an emergent property of complex matter. Growing evidence suggests that consciousness might be fundamental to reality itself, not produced by the universe but rather producing the universe through observation and interaction. The quantum measurement problem suggests that consciousness plays a crucial role in actualizing physical reality. The fine-tuning of physical constants seems designed to support the emergence of conscious observers. The mathematical nature of reality appears calibrated for minds capable of mathematical understanding. What if consciousness is not the accidental byproduct of cosmic evolution but its intended outcome? What if the entire universe exists as a vast project to bring conscious awareness into being? This would explain the apparent design we observe throughout nature. The fine-tuning of physical laws, the emergence of complexity, the development of life, all of it would be stages in the universe's project to create conscious observers capable of understanding and appreciating existence itself. In this view, we are not accidents in an indifferent cosmos, but the culmination of a cosmic process billions of years in the making. The universe spent eons preparing for conscious beings to emerge and begin the task of cosmic self-understanding. But consciousness might also be the universe's way of transcending its current limitations. Through conscious beings, the cosmos gains the ability to contemplate alternative realities, to imagine different physical laws, to envision new forms of existence. Perhaps we are witnessing the universe's transformation from a purely physical system into something more. A conscious cosmos capable of redesigning itself, of creating new realities, of transcending the boundaries of space and time. As we near the end of our journey through the evidence for cosmic design, we're left with profound questions that challenge our deepest assumptions about reality. If the universe is designed, what does this mean for our understanding of existence itself? Are we living in a purposeful cosmos where consciousness and complexity are not accidents but inevitabilities? The evidence we've examined, from fine-tuning to mathematical harmony, from information processing to quantum consciousness, all points toward a universe that seems almost too well-crafted to be accidental. The precision required for stars to form, planets to develop, life to emerge, and consciousness to evolve suggests planning and intention on a cosmic scale. But this raises even deeper questions. If there is design, what kind of intelligence could be responsible? Are we dealing with a transcendent designer operating from outside space and time? An advanced civilization from another universe or dimension? A distributed cosmic consciousness of which we are all part? Perhaps most intriguingly, what if the designer is us not as we are now, but as we might become? What if consciousness, having emerged from the cosmic process, eventually develops the ability to reach back through time and fine-tune the very conditions that gave rise to its existence? This would create a kind of cosmic bootstrap paradox. Consciousness creates the universe that creates consciousness. The fine-tuning would be the result of future conscious beings ensuring their own past existence. Or perhaps we're witnessing the universe in the process of designing itself. Through the emergence of consciousness and intelligence, the cosmos gains the ability to understand and modify its own structure. We might be part of the universe's transition from a purely physical system to a conscious, self-designing reality. The possibility of cosmic design has profound implications for how we understand science, philosophy, and our place in the universe. If the universe is designed, then science is not just discovering natural laws but uncovering the principles and intentions of the cosmic designer. Scientific research becomes a form of archaeology, excavating the deep structure of a purposefully crafted reality. This doesn't diminish the importance of science, it enhances it. Understanding a designed universe requires even greater scientific sophistication than understanding a random one. We must not only discover what the laws of physics are, but why they take the specific forms they do. The possibility of design also transforms our understanding of consciousness and intelligence. Instead of being mere byproducts of mindless processes, conscious beings become participants in the cosmic project of self-understanding and self-creation. This has ethical implications as well. If consciousness is the intended outcome of cosmic evolution, then conscious beings have a special responsibility to preserve and enhance awareness, understanding, and experience throughout the universe. The designed universe hypothesis also suggests that reality may be far stranger and more wonderful than we currently imagine. If consciousness can emerge from matter, what other miraculous transformations might be possible? What other levels of existence and awareness might the universe be capable of supporting? Perhaps most importantly, the evidence for design suggests that existence itself is meaningful. We are not accidents in an indifferent cosmos, but participants in a grand project of cosmic awakening and self-discovery. Of course, the question remains, how could we ever prove that the universe is designed? Traditional scientific method relies on forming hypotheses and testing them through experiment and observation. But cosmic design operates at scales of space and time that make direct testing impossible. We cannot rerun the universe with different parameters to see what happens. However, there are several ways we might gather evidence for or against the design hypothesis. First, we can continue to investigate the fine-tuning of physical constants. If future discoveries reveal even more precise calibrations required for complexity and consciousness, the design hypothesis becomes more plausible. Conversely, if we find natural explanations for apparent fine-tuning, the design hypothesis becomes less necessary. Second, we can search for patterns and structures in the universe that suggest intentional organization. The more systematic and purposeful the cosmic architecture appears, the more it suggests design rather than accident. Third, we can investigate the nature of consciousness itself. If consciousness turns out to be fundamental to reality rather than emergent from matter, this would support the idea that the universe is designed to support conscious experience. Fourth, we can look for evidence that we're living in a simulation or computational universe. Digital signatures in physical phenomena could reveal that our reality is a design system running on some vast computational substrate. Fifth, we can search for direct communication from the cosmic designer. This might take the form of encoded messages in physical constants, cosmic structures, or even biological systems like DNA. Sixth, we can investigate whether the universe shows signs of optimization and improvement over time. A designed universe might be self-modifying, constantly updating and refining its structure to better support complexity and consciousness. Whether or not the universe was originally designed, it seems clear that conscious beings are now becoming capable of design themselves. Through science and technology, we're beginning to understand and manipulate the fundamental forces of nature. We can alter matter at the atomic level, engineer biological systems, and even manipulate space and time on small scales. As our capabilities grow, we may eventually develop the ability to create new universes with different physical laws. We could become cosmic designers ourselves, crafting realities optimized for different forms of consciousness and experience. This raises profound questions about our responsibilities as potential universe creators. What ethical principles should guide the design of new realities? What obligations do we have to the conscious beings who might emerge in universes we create? It also suggests that the design question might eventually become moot. If conscious beings inevitably develop universe-creating capabilities, then all sufficiently developed realities will show signs of design, not because they were originally designed, but because consciousness naturally leads to design. Perhaps the universe we observe represents an intermediate stage in cosmic evolution, no longer purely natural, but not yet fully designed. We might be witnessing the universe's transition from accidental complexity to intentional creation. This transition could explain many of the patterns we observe. The fine-tuning might reflect the beginning stages of cosmic self-optimization. The emergence of consciousness might mark the universe's first step toward self-awareness and self-modification. If this is true, then we are living through one of the most remarkable epochs in cosmic history, the moment when the universe first becomes conscious of itself and begins to take control of its own evolution. Ultimately, the question of cosmic design is really a question about the meaning and purpose of existence. A randomly generated universe, no matter how vast and complex, is ultimately meaningless. Events occur, structures form and dissolve, but there's no overarching purpose or direction. We are accidents in an indifferent cosmos, brief sparks of consciousness in an infinite darkness. But a designed universe is inherently meaningful. Every structure, every process, every event serves some purpose in a grand cosmic plan. We are not accidents, but intended participants in the universe's project of self-understanding and self-creation. This doesn't necessarily imply a traditional religious worldview. The cosmic designer might be an advanced civilization, a distributed intelligence, or even our own future selves reaching back through time. The design might be purely aesthetic, or it might serve purposes we cannot yet comprehend. But it does suggest that existence has significance beyond our immediate experience. We are part of something larger than ourselves, a cosmic process that has been unfolding for billions of years and may continue for billions more. The evidence for cosmic design also suggests that consciousness and intelligence are not mere accidents but fundamental features of reality. The universe appears to be organized not just to support physical processes but to generate awareness, understanding, and experience. This elevates the importance of conscious beings in the cosmic scheme. We are not just observers of the universe but participants in its evolution. Through our scientific investigations, artistic creations, and moral choices, we contribute to the universe's ongoing project of self-development. Perhaps most importantly, the design hypothesis suggests that the future is open and full of possibility. If the universe is indeed designed to support the emergence and development of consciousness, then conscious beings have the potential to transcend their current limitations and participate in cosmic processes we can barely imagine. As we conclude our exploration of cosmic design, we find ourselves facing a profound shift in how we understand reality itself. The evidence we've examined, from the fine-tuning of physical constants to the emergence of consciousness, suggests that our universe displays patterns, precision, and purpose that are difficult to explain through random processes alone. The mathematical harmony underlying physical laws, the optimal solutions discovered through biological evolution, the information processing nature of quantum mechanics, all point toward a reality that seems crafted rather than accidental. This doesn't require us to abandon scientific thinking or embrace supernatural explanations. The cosmic designer might be an advanced civilization from another dimension, a distributed intelligence inherent in the fabric of space-time, or even our own future selves reaching back through time to ensure their existence. The design might emerge from computational processes we're only beginning to understand, or from principles of cosmic evolution that transcend our current knowledge. What matters is not the identity of the designer but the implications of design itself. If the universe is purposefully structured, then existence has meaning beyond our immediate experience. We are not accidents in an indifferent cosmos but participants in a vast project of cosmic awakening and self-discovery. The fine-tuning of physical laws suggests that the universe is optimized for complexity and consciousness. The emergence of life and intelligence appears to be not just possible but inevitable given the right conditions. The mathematical nature of reality implies a deep connection between mind and cosmos. But perhaps the most profound implication is that we are living through a unique moment in cosmic history, the epoch when the universe first becomes conscious of itself. Through conscious beings like ourselves, the cosmos gains the ability to understand its own structure, contemplate its own existence, and potentially redesign itself for even greater complexity and awareness. This transforms our understanding of human purpose and responsibility. We are not just observers of cosmic evolution but active participants in it. Our scientific discoveries reveal the universe's deep structure. Our artistic creations add beauty and meaning to existence. Our moral choices help determine what kind of reality emerges from the cosmic process. If the universe is designed, then we are both products and inheritors of that design. We carry within us the patterns and principles that structure reality itself. Through us, the cosmic designer, whatever its nature, continues its work of creation and discovery. But we are also becoming designers ourselves. As our understanding and capabilities grow, we gain the power to modify matter, life, and perhaps eventually the fundamental forces of nature. We stand on the threshold of becoming cosmic engineers, capable of crafting new realities and new forms of consciousness. This brings both unprecedented opportunities and profound responsibilities. If we are to become universe designers, we must develop the wisdom and ethical principles necessary to use such power well. We must ask not just what we can create, but what we should create. The question of cosmic design also opens up extraordinary possibilities for the future. If consciousness is fundamental to reality, then there may be forms of awareness and experience far beyond anything we currently know. If the universe is computational, then we might eventually learn to program new realities with different physical laws and possibilities. Perhaps most exciting is the possibility that we are part of an ongoing cosmic awakening, a process by which the universe gradually becomes more conscious, more intelligent, and more capable of understanding and improving itself. Each generation of conscious beings might contribute to this awakening, building on the discoveries and creations of those who came before. In this view, scientific research becomes a form of cosmic archaeology, uncovering the deep principles that structure reality. Artistic creation becomes cosmic design, adding new patterns of beauty and meaning to existence. Moral development becomes cosmic evolution, helping to determine what kind of universe we collectively create. Whether or not the universe was designed from the beginning, it is becoming designed through us. We are the universe's means of understanding and recreating itself. Through our minds and hands, the cosmos gains the ability to transcend its current limitations and evolve toward new forms of existence. This perspective doesn't diminish the mystery and wonder of existence. It deepens them. A designed universe is far more mysterious than a random one, because it implies intelligence and purpose operating on scales we can barely comprehend. It suggests that reality has depths and dimensions that we have only begun to explore. As we stand on the brink of becoming cosmic designers ourselves, we face questions that would have been pure fantasy just centuries ago. What kinds of universes should we create? What forms of consciousness should we nurture? How can we ensure that the cosmic project of awakening continues and flourishes? These are not just philosophical questions, but practical ones that may determine the future of consciousness itself. The evidence for cosmic design suggests that we are not alone in the universe, not because there are other biological species like us, but because we are all part of a vast intelligence that permeates reality itself. In the end, the question of whether the universe was designed may be less important than recognizing that it is becoming designed through us. We are both the product of cosmic evolution and its current agents. Through our choices and actions, we help determine what kind of reality emerges from the ongoing cosmic process. The universe has spent 13.8 billion years preparing for this moment, the emergence of conscious beings capable of understanding and reshaping reality itself. We are the universe's first attempt at self-awareness and self-modification. What we do with this unprecedented responsibility may determine not just our own future, but the future of consciousness throughout the cosmos. The evidence for cosmic design suggests that we live in a meaningful universe where consciousness and intelligence are not accidents but inevitabilities. If this is true, then every conscious being has cosmic significance. Every act of understanding, creation, and moral choice contributes to the universe's ongoing project of self-discovery and self-improvement. We are not just observers of cosmic evolution, we are its current leading edge. Through us, the universe contemplates its own existence and plans its own future. We are both the question and the answer, the seekers and the sought, the designers and the designed. In a universe that may have been designed for consciousness to emerge, we face the ultimate challenge: to prove worthy of the cosmic investment in our existence. To use our awakening awareness not just for our own benefit, but in service of the greater awakening of which we are all part. The cosmos has given us the gift of consciousness and the tools of science. How we use these gifts may determine whether the universe's experiment in self-awareness succeeds or fails. The evidence suggests we live in a reality optimized for consciousness and intelligence to flourish. Now it's up to us to justify that optimization, to prove that consciousness was worth the 13.8 billion years of cosmic evolution it took to produce us. The universe has made us in its image, conscious, creative, and capable of design. Now we must decide what to do with that cosmic inheritance.